So last time you already learned about what is V source dengan V peak and what is the difference lah between V RMS dengan V peak. I hope by now you understand lah. And then we also learn about the equation here. When the V and I is dependent with time, kalau dia bergantung dengan time lah. So we have this kind of equation. And equation ni they really depends on the graph. So if your graph is like a sine graph, then you expect that it has to be a sine graph as well. Okay, and then you learn about 6 types of circuit. You have pure resistor, pure capacitor, and pure inductor. And then we have RC, RL, RSC. So by now rasanya kamu dah ingat kot langit, cacing dengan rumah tu. And you need to be able to draw the phasor diagram. Phasor diagram tu dia jarang tanya directly lah. Dia jarang tanya, please draw the phasor diagram. But you need to apply phasor diagram in your calculation. So my suggestion is that once you get the question, you try to draw it. So today we continue with AC circuit, okay, where we involve with the circuit that has alternating current as the source. So we're going to focus on resonance in AC circuit. Okay, so far any question?
No sir.
No. Okay, when I talk about resonance, apa yang first thing yang kamu terfikir? Ramai ni yang kelas.
Fenomena ke sir?
Yes, it's a phenomena. Phenomena about what? Kalau kita cakap pasal resonance, benda pertama saya rasa kalau kamu teringat,
Frekuensi.
Frekuensi. And then kalau kamu teringat video yang pasal jambatan tu, ingat tak?
Ingat sir.
Ingat So bila frekuensi ataupun jambatan tu dengan frekuensi persekitaran tu sama, itu adalah resonance. So the key term here, dia ada sama frekuensi. So this is actually is defined as the phenomena that occurs when the frequency of the RCL circuit. So basically that's the key thing. But the main thing is that it is actually applied this condition where XL equals to XC. Okay, this is when you know that AC circuit is at resonance. So this is the condition. So previously, if you guys still remember, kita ada belajar pasal resistor, which does not depend on frequency. Dia tak berubah. It's a constant. With frequency. Okay, and then we have equation of XC. Apa equation XC? Tak.
1/2
Yes. 1/2 pi F multiplied with capacitance. And then we have XL, which is 2 pi FL. Okay, so you know that these two, XC dengan XL is actually frequency dependence. So when you have change in frequency, you expect to have a change in XC and XL as well. Okay, macam mana dia berubah? Okay, if I were to write the dependence, then I can write that XC is inversely proportional to the frequency, 1/X, ataupun 1/F lah, sorry. Then this one is directly proportional, XL directly proportional to the F. Okay, so far boleh ikut?
Boleh sir.
Ada masalah tak?
Tak ada.
So, tak ada. Okay. So, if I were to draw the relation on a graph, macam ini saya tak lukiskan, saya tulis. So, if I were to draw a graph of let's say this one is your resistance, tapi saya tak tulis dulu, saya just tulis dia punya unit dulu, ohm. And this one is the frequency. Contoh Okay, if I were to draw the relation of Yang paling senang sekali XL dengan F. Saya punya bentuk graf macam mana? Saya punya XL dependence with the frequency is directly proportional. So graf saya macam mana bentuk ni?
Lurus
Mana?
lurus.
Lurus.
Okay,
Linear,
dia
linear.
adalah lurus. Okay, good, very good. It's a linear graph. So maybe I can write this one in terms of green color. Okay. So it is actually a straight graph like that. So this one agree with the relation of XL directly proportional to the F. Okay. How about my XC? Graph saya macam mana?
Curve sir, curve.
Curve. Okay, very good. So to be exact, the curve yang decreasing. As frequencies increase, kan? Ini frekuensi naik, so that means your XC will decrease. Macam mana decrease dia? The curve, exactly, correct. Look something like this. Maybe change this one. Okay. So this one is actually XC that depends on the frequency 1 over F. Okay. How about my resistor? Resistor saya tak berubah with respect to time, but it stay at the one particular values lah. So if I were to draw, dia mestilah straight line. Dia tak berubah dengan frequency. So let's see if I draw it over here. So this would be my resistance R. So it's a constant. Okay, so it is a constant with respect to frequency. Does not depend on the frequency. Okay, and then one more thing that you learned yesterday is about Z. Ingat lagi tak Z tu apa? Yesterday depends on kelas bila. Okay, Z tu apa?
MP10.
Impedance. Impedance tu adalah mark pada segala resistance, the total of the resistance. So let's see if I write it over here. So the Z, if you guys still remember, it is actually equal to square root of R square plus XL minus XC square. Okay, it depends on XL and XC lah. So kalau XL ni macam ni, contohnya at low frequency, you expect belah side sini lah. At the low frequency, XC is big, okay, XL is small, and then it's about the difference here. Then you take square, tak kisahlah mana besar mana kecil kan. So you can add up this one. So in the end dia akan jadi something like this. Kalau nak dapat macam mana dapat benda ni, dia kena masukkan nilai satu persatu. You have to substitute at each value of F yang ada dalam XL dengan XC ni, and then you get a different value of Z. But as a result, you will have something that looks like this. Okay. So kalau kamu ni, kamu boleh terima je lah dia bentuk itu. Macam mana dapat the plot actually one frequency. That's more like direct correlation or 1 over X. Bahagia macam ni. Okay, and then this one is your Z. It is basically the resistance lah. Okay, so far any question?
No sir.
Tak ada. Okay, if you go back to the initial condition yang XL sama dengan XC ni, and if you look over here, masa bila dia sama? XL, the green line, and then XC is the red line here. So when is the time ataupun where is the position when these two is equal? So saya tanya, saya jawab. So obviously it is at the intersection point. Agree ke tak? So this is when your this is at your frequency resonance when XL is actually equals to XC at this particular position. Kenapa? Because your XC dengan XL has the same value. This is the only intersection point lah. Boleh ikut tak?
Faham sir.
Tak? Faham Okay. So there's two things that you can get from here. Okay, number one. Dua ke? Ketiga. Tidak apa. Okay. Kita pergi satu-satu. At this particular point, maybe I can take this equation, I can bring it down here. Maybe I can expand the equation a little bit more. Okay, let's see if I were to expand the equation a little bit more. XL equals to XC. Okay, if I substitute formula of XL and XC, it will be 2 pi FL equals to 1 over 2 pi FC. But remember, this is at frequency resonant, so it is a specific value. Dia ni satu circuit ada satu value. It depends on the circuit. It depends dengan values of XC and XL to itself. Dengan R lah. So satu circuit ada satu value FR. Okay, back to this one. So if I were to rearrange, I can bring the FR up here. It becomes FR square. Then I can bring everything else down here. It becomes 2 pi. This one is square because you get twice the 2 pi. And then L and C. Okay. If I were to take the square root, then it becomes 1 over 2 pi square root of LC. Kita ada benda tak? Okay. Okay, so this is the first thing that you get from the resonant frequency. This is what happened. Okay, you have XL equals to XC, and as a result, if I want to calculate the FR, I can use this formula. Okay, understand or not?
Understand, sir.
Sometimes dia tanyalah dalam soalan, find the frequency resonant. How to calculate the frequency resonant? You can use this formula and you just substitute the values of L, inductance. Ingat L bukan XL. Dia adalah L dengan C. Then you can get the frequency resonant. What is so special about this frequency resonant? Dia ada dua benda. Okay, thing is number one. At this particular line, at this particular position, you can see that apart from this one is at the same point, this one is also at the same point. And this one is actually at the lowest point. The Z is actually at the lowest point, and it is actually equals to R. So I can write here as at FR, when it is the resonant frequency, the Z is at minimum. And this one is equals to the resistor. So you can see back at this equation, you can refer to this equation, when XL and XC has the same value, so that means XL minus XC will become 0. Okay, that's why Z equals to R when this one is at the resonant frequency. And this would be the minimum Z. Okay, itu yang satu benda yang kita tahulah. And then when Z is at minimum, okay, let's see if I want to find, if I were to write V equals to I, instead of IR, I have to write IZ because this one involves more than one component lah. So if Z is mean, that means my V is, Z is mean, current is max. Okay, sebab apa? Satu tu turun, satu tu naik. Sebab power supply is still the same. Tapi yang this one kita jarang pakai lah. Normally we are not going to use this condition, so maybe I can bring it a little bit further down there. That's tak significant sangat. The two significant things is actually Z mean equals to R, and then XL equals to XC. Dua benda ni. So obviously this one you can derive, you can expand a little bit more and you get this equation. Okay, so ingat ulang. AC circuit, you only have one values for resonant frequency. So you have a few component inside a circuit. Tapi for one particular circuit, you only have one value. That value is when XL equals to XC. To calculate, you can use this formula. And one of the key thing here is that at resonant, Z min is equals to R. Dia sebenarnya ada significance dia dekat power. Tapi sebab saya tak belajar di power, dari kita masuk, mungkin saya boleh sentuh lah what happen when you have a Z minimum. Okay, so far ada soalan tak? Are you guys okay?
No, sir.
Masih wujud?
No, sir.
Okay, sir.
No, dah tak wujud. Okay. No. Okay, we are moving on to the last. Okay, we moving on to the last subtopic of this chapter. Okay, the last subtopic is about power and power factor. Okay, so the learning outcome is this one lah. This one just roughly the learning outcome. So you have few formulas that you need to know. Number one is P average equals to I RMS V RMS phi, and then you know about P instantaneous, P equals to IV, and then cos phi equals to PR over PA or PA over IV. Okay, jadi saya tunjuk. Dia akan write it down here. Okay, if you guys still remember, you have the formula of P equals to IV. Okay, but remember, for let's say if you have multiple component in a circuit, you have a resistor, you have a capacitor, you have the inductor here, and it is connected to a power supply. Okay, if you want to find the power in this circuit, the source of power will only come from the resistor. These two does not produce any power. Dia tak ada power loss dekat sini. Kenapa tak ada power loss? Because there's no R. So if you guys still remember, the formula for power is P equals to I squared R. So R only over here lah. So the key part here is that the power only dissipated by the resistance. Okay, the key thing here is that power only dissipated at resistor. Okay, tolong understand this part and tolong ingat seperti dulu lah. Power only dissipated at resistor. Okay, if I want to use the equation P equals to IV, okay, I have to use my V to be my R. So let's say if I want to find the P average, dia ada dua P je sebenarnya, P average dan P max. So if I want to find my P average, I need to use V as my VR. Okay. So, voltage across the resistor multiply with the IRMS. So IRMS kita boleh tulis I je lah, tak ada masalah sebab we are only talking about one types of current. Dia tak ada current banyak sebab this one everything is in series. Okay. If I want to use P equals to IRMS, okay, let's say if I want to write P average equals to IRMS V RMS. Boleh pakai equation ni dengan syarat you have to include cos phi. Okay. Why do you have to include a cos phi? Because basically, if I want to draw my langit touching dengan tu, let's say if I want to draw langit touching dengan R, so let's say my V RMS is over here. This would be my phi, phase angle. Okay. If I want to use Rms Pulley dengan syarat, you need to write, you still have to use VR lah. So VR here is equals to, let's say if I write cos phi. Cos phi is equals to adjacent per hypotenuse. So it will be VR divided by Vrms. So my VR actually you can write as if this one is equals to VRMS cos phi. So you can use VRMS with a condition that you need to use cos phi. Okay, because sometimes in exam they didn't give you the values of VR. Jarang-jarang dia kasih VR. So very unlikely you can find straight away using this formula. So the tricky part here, they give you IRMS and VRMS. So you have to include cos phi. Okay, so that's the idea. Okay, cos phi ni pun ada significant dia. Cos phi ni adalah power factor. Okay, so cos phi is actually power factor. This is what we call power factor. It indicates how efficient the circuit is, and it indicates circuit tu efficient ke tak lah. Okay, if you have cos phi equals to cos 0, then you have 1. If you have cos other than 0, then you have less than 1. So power factor you can write as if R over Z. Biasa kita pakai R over Z. Saya tak fikir ada question lain tak? Okay, normally we use R over Z. Daripada mana datang R over Z ni? Actually, it comes from the same phasor diagram. If you guys still remember, yesterday saya ada tunjuk. Not only can you write VL, VRMS, VR, and VC, you can also write this one as XL, Z, R, and XC. So if I want to write cos phi here, it will be adjacent, masih sama, over hypotenuse. But instead of writing VR over VRMS, like I write it over here, so I can also write this one as R over Z. Sebab the thing is, in the first place, kamu nak kena pakai equation ni sebab kamu tak ada VR. If I want to use this one, then I still don't have my VR. So what's the point then? VR, I still don't have the cos phi, sorry. Kalau saya nak pakai yang cos phi equals to VR over VRMS, boleh juga. Tapi saya sikit tak ada VR. Itu maksud saya. So now you have to use this equation instead. So if you divide R by Z, you get cos phi, and then you can substitute inside here, and so we can find the P average. Okay, faham ke tak? Tapi kan, my advice is, if you have R, alright, always try to use P equals to I square R. Kalau saya masih pakai I square R, dan saya nak pakai benda lain, normally I will use P equals to I square R. Because if you use I square R, immediately you use R lah. So memang takkan salah. Tapi for some reason, student dia nak juga pakai IRMS, VRMS. So common mistake, student forgot to include this one. Dia terlupa pasal cos phi, ataupun dia salah kira cos phi. So that is the problem. Yeah, but if you use I square R, you can straight away. Tak perlu pakai, you don't have to put the cos phi, which is much easier and straightforward. Okay, one more thing that you need to know is about apparent and average power. Jadi saya tengok nota kamu ada tak? Tak ada.
Tak ada, sir.
Tak ada Okay, at the same time, cos phi tu juga is actually equals to, maybe I can bring this one a little bit further. So, dia dah tak ada dalam nota kamu. Saya takut dia sama ada terlupa tulis ataupun dah close. Saya rasa tak ada dah close syllabus. Anyway, cos phi ni juga, you can write this one as PR over P average. Okay, saya maybe kena check kamu punya formula sheet. Okay, if you look at your lecture notes, sorry, buku tutorial, kamu ada buku tutorial with you tak? Ada tak buku tutorial?
Ada sir.
Ada Okay, maybe try to look at the formula in front of the book. Saya double check. Formula ni saya selalu tersalah tulis.
Sir, formula yang PR over I square Z tu ke?
PR over PA. Apa? Kamu cakap apa? Tak dengar.
PR I square Z.
I square Z. Okay, that one pun ada juga, I square Z. But if you use I square Z, kena letak cos phi juga. Jadi saya tak tekankan. Okay, itu formula tu betul juga tak masalah. Cuba kau tengok formula nombor 62 sampai 65. Okay, 62 tu cos phi sama dengan R over Z. That one we already discussed. 63 P average equals to I RMS V RMS cos phi. That one pun we already discussed. P instantaneous kita akan discuss sebentar saja lagi. And the last one is about cos phi equals to PR over PA. Bukan P average saya tulis. Okay. PR
Adalah
is
sedar.
actually, ada kan? Di dalam kotak kecil tu.
Ada.
Okay. PR tu is actually the average real power. So biasa kita pakai dia sebagai real power je lah. So ada dalam syllabus real power. And this one adalah apparent power. Okay, apa beza dia? Saya nak kamu Google and find out. And then lepas ni kamu beritahu saya apa beza between real power and apparent power. Apa beza term tu? Ya? Bukan sebab saya tak ingat, tapi saya nak kamu Google. Okay, anyway, lagi satu type of power. Just now, all the time, we only talk about average power. Okay? So now we want to talk about instantaneous power. Dia obviously ada peak power dengan instantaneous power. Peak power tu you have to be careful a little bit. Dia kena tulis and then kamu akan dapat lah question dia. But we want to talk about instantaneous power. So, mana pula saya tulis? Okay, now I want to talk about instantaneous power. Okay, hopefully saya tak salah je. For instantaneous power, okay, if I want to use, I have to use P equals to IV. Okay, dia jarang tanya, dah lama tak tanya. Hopefully dia tak tanya. Kalau dia tanya juga, senang je. The thing is, instantaneous is about a specific time. Dia dekat certain time. Dekat waktu yang tertentu. Okay. So, what you need to do is that you have to substitute I dengan V ni, yang formula dia ada time. So that means I that varied with time and V that varied with time as well. So equation ni anda nak dapat dalam soalan berbeza. So you might have a different type of question. Macam saya cakap lah. Dan soalan dependence dan time tu dia jarang tanya. That's why soalan ni pun dia tak tanya sangat. But kalau ditanya jangan terkejut lah. And tak adalah siapa nak jawab. Okay. So far ada soalan ke tidak? Ada tak soalan? So today kita belajar dua benda power dengan resonance. Any question on this two?
Tak ada.
Tak ada. Saya tak ada. Sekejap setelah okay, sebenarnya kita dah basically chapter 6 kita dah habis cover. Saya nak cari soalan. Okay. We try to discuss one question from the past year. Saya nak copy. Okay, cuba kamu kalau kamu ada nota buku tutorial, you can open up the past year. Maybe you can try to look at question number 4 kot. Okay, this one is question number 6. We can try to look at question number 4. Okay, jadi kita boleh try bincang dengan question A tu. Take this one, put it on the here. So PSPM 2014-2015. It's about alternating current. Okay, kita bincang sekejap. Kita ada masa lagi, we discuss the trick. Okay, since kita dah habis ni, I think after this class saya akan buat record video untuk ni kot. Untuk tutorial dengan pasal a little bit. Okay, if you are reading this question, okay, soalan dia kata an RS series circuit with 0.056H and 250 ohm resistor is connected with a source of peak voltage 240 volt at the frequency of 200 Hz. Calculate inductive reactance, impedance, power factor, RMS voltage and average power. So all the things that we learn lah. Soalan ni pendek-pendek je. Dan dalam example macam tu juga biasanya. Bakal ada berapa ni? Saya dah tutup. So kita tahu bakal ada berapa. Okay, anyway. First thing first, you take out the information. It is a RS series circuit. So ada komponen apa dalam dia? RL ada apa? You guys okay? You guys with me or not?
Yes.
Yes. Kalau RS circuit ada komponen apa? Yes.
Ada resistor.
Okay, ada resistance and
formula.
okay, ada resistance and inductor. So this one is actually the values for inductance and this one is value for resistor. Okay, the peak source is 240 volt and the frequency is 200 Hz. Okay, first maybe you can try to draw this circuit. Okay, try draw. So dalam example, I strongly suggest you to draw the circuit. Okay. So this is my circuit. Kita ada RS circuit, so ada resistor, and then inductor, and then kita ada power supply over here. Okay, so values of 0.056, look at the unit. That one is Henry, that one is L. Okay, R is equals to 250 ohm. Okay, peak voltage. Peak voltage tu apa?
VR, VR. VP. VP.
V0.
V0. Okay, kalau VT tu biasa kita pakai untuk direct current lah. Tapi biasanya ni sebab kita ada AC, kita pakai V0. Okay, the frequency is equals to 200 Hz. Okay, V0. Okay, the first question, they ask you to calculate the inductive reactance of the circuit. So soalan ni nak apa? Number 1.
XL.
Inductance.
Yes, XL. So if I were to calculate, XL equals to 2 pi FL, which is equals to 2 pi, frequency is 200 Hz, inductance is 0.056.
70.37.
70.37, thank you. Okay, that was for question number 1. Number 2, impedance. Impedance simbol apa?
XL juga. Z.
Z, sir.
Z. Okay, good. So if you
Guna
want to
Pythagoras theorem.
yes. Okay, kalau saya nak calculate Z, macam kamu cakap lah, dia ada banyak cara sebenarnya. You can simply use the formula yang Z equals to R square minus plus X1 tu, lepas tu tutup yang lain tu kan. Ataupun, my suggestion is that you try to draw the phasor diagram. Yeah? If I were to draw my phasor diagram, so this one is ada L dengan R. So VL tu ke mana? VL kita tahu ke kanan. How about my VL? Atas ke bawah?
Atas, sir.
Atas langit.
Langit, sir.
Yes. So I can write this one in terms of VL ataupun saya boleh tulis dia sebagai XL. So I want to write in terms of XL here lah. So this one is resistor. The current is in this direction, I. Okay, and this would be my Z. Okay, so based on this phasor diagram, Z is equals to XL square plus R square. And then take the square root. So it will be R square plus XL square. So it will be 250 square plus XL, kita dah kira tadi, 70.37 square. Okay, press your calculator, you should get berapa ni?
259.72.
7. Okay, good. So, question number 3, power factor. Power factor is apa? Apa formula power factor?
P over P max.
Betul? Okay. Tapi sebenarnya power factor ni simbol apa kita nak tulis? Okay, ni yang ramai sudah confuse. Student ingat, power factor ni adalah phi. Bukan power factor adalah cos phi. Kamu jangan cari phi, dia nak cos phi. Itu yang ramai student salah faham. So, you know that the phi is the angle over here. So, if I want to find my cos phi, will be adjacent over hypotenuse, which is R over Z. Yang kamu cakap tadi betul tak? Yang P tu kan? Tapi sebab we don't have those value, so you can simply refer to your phasor diagram. That's why phasor diagram is very important. It tak directly ask you, but you need to be able to use this one lah. So in this case, cos phi is basically just this is the phi adjacent over hypotenuse. So you will get R over Z, which if I substitute all the values will be 250 divided by 259.72, which is equals to 0.96 3. Okay, this is the power vector factor. Jangan cari phi, jangan letak cos pula, biar je macam ni. This is the answer. Biar je macam tu. Okay, so far can you guys follow?
Yes,
Okay,
sir.
sir. Boleh, sir. Boleh.
Okay, sir.
The next question is question number 4. They want to find VRMS. So VRMS is VRMS lah. They give you V peak. Like, instead, you want to find the VRMS. So VRMS equals to V naught over square root of 2. So masuk je lah. So it will be 240 divided by square root of 2.
169.7.
Okay. And the last question they ask you to find the P average. Okay, bukan P peak, bukan P instantaneous, but P average. So how do you want to solve this one? You can use R squared R. But if you want to use I squared R, you have to find the I first lah. Kalau nak cari I, you need to use V equals to I Z. I remember that lah. But in this case, I think the simplest way is clear. Paling senang. Sebelum kita pakai cara yang saya cakap tadi. Okay, let's try to find using those methods. So basically, I want to use P equals to I squared R. Macam saya cakap lah, if you use this one, confirm dapat. It's just that you have to find the I first. If I want to use I, ramai student dia akan salah dekat sini. Dia akan pakai V RMS, I RMS, R. Itu yang salah. Dia bukan R, dia sepatutnya adalah apa?
Z.
Z. Okay, kenapa dia Z? Sebab the combination of the combination of resistance. So you cannot use R, but you have to include all the R. Z tu equals to 259.72 tadi we calculated. So I equals to V RMS, which is 169.71 divided by Z, which is 259.72. So here I got 0.65. Betul tak?
Betul.
Okay, that one is your values for I RMS. Kadang-kadang tak tulis tak apa RMS biasa. Okay. So now you substitute back inside the equation. P equals to 0.65 square multiplied with the resistance, which is 250. So what I got here is 105.62. So obviously if you use a different formula, you might get a slightly different answer, but it doesn't matter. Right? The most important part is that you use the correct technique. So it might be rounding off difference. Just let me check my calculation. If you use 3 decimal place over here, let's say if you use 0.653 over here and here, then I think you get something that is much closer, which is 106.6 compared to the answer lah. It doesn't matter pun. Okay? Faham ke tidak?
Faham, sir.
Faham, sir.
So the P average ni is something that I'm worried about because student biasanya dia confused. Soalan dia tanya apa? Even when student understand soalan dia tanya P average, still ada student salah masuk nilai dalam formula. But that one is just a small part of the question. The large part of the question is actually senang aja. They ask you to find XL, Z, cos, betul lah. Kalau dia kata nak cari resonant frequency ni, cari je. Salah. Okay, before saya tutup this one, saya nak goes back to the average power tadi. Bila saya nak tunjukkan pasal this one. Okay, so if you notice over here, P average equals to I RMS V RMS cos phi. Saya dah cakap tadi kan, at resonance dia ada effect dekat P average. Masa bila the effect is actually inside here, inside the cos phi. Okay, if you still remember, I can write it over here. Kejap I'll take this one. It's gonna be over here. So basically this is the equation of P average. But notice that we have a cos phi over there. The cos phi, as you guys know it is actually equals to R over Z. Ini dah memang well-known lah. But at resonant frequency ataupun when XL equals to XC, go back to this graph, you will see that here Z is equals to R. Okay. So Z is equals to R. Therefore, your cos phi becomes 1. Okay. So this is another important properties of at resonant frequency. So R and Z is the same value, potong-potong jadi satu. Okay. So the one comes from into here. So you can write this one as P average equals to I RMS V RMS 1. Okay. This one is when you have the maximum power. Tapi saya tak payah cakap pasal itulah. But at resonant frequency, power factor becomes 1. The circuit is more efficient. Okay, ada soalan tak?
Tak, sir.
Okay, kalau tak ada soalan, maybe you can stop here today.